Welcome to the project demonstration of fault detection in transformers using GSM technology along with IoT messaging system. So here we are going to identify the fault in this transformer. So the load is connected DC motor, and here we are using the two transformers. One is a potential transformer, another is a current transformer. These two data will be monitored by the PIC microcontroller, as well as if is there any abnormality detected from this PT and CT. Nothing but potential transformer and current transformer. The differential will be identified by the PIC microcontroller, and it will send the message alerts using the GSM modem, and also it will send the continuous data streaming through the IoT using ESP8266. Here also the data will be continuously monitored on the 16:2 LCD screen, as well as if in abnormal cases we will get the audible alerts through the buzzer also. So here this one is a potential divider circuit in order to check the current values from the current transformer, and potential transformer will be connected at this shown slot, like PT, and here we need to connect the CT, and these two sensors are interfaced to the A0 and A1 pins of the PIC microcontroller. Here we are using PIC 16F876A. That's a PIC family microcontroller. And coming to this inputs, so let us see the input flow. So we are going to provide the 230 volts power supply from the cable, and the PT will be divided that 230 to 12 volts of AC, and the particular signal 12 volts AC will be given through these wires, and we need to connect that in the PT shown section. And next, so these are parallelly connected, and after that the load will be given through the current transformer. So the input given to the CT and the output to this rectifier circuit. So this is the DC rectifier circuit which will convert the AC to DC. So on this PCB we can see the 4 diodes which are used to convert the AC to the pulsating DC, and after this capacitor we will get the pure DC, and that DC voltage will be given to the DC load. So that is a 12 volts operated DC motor. So there will be a LED indication, and so from here, as we know that the voltage is monitored from these wires, and the CT has to be connected here. So as we know that CT nothing but current transformer is a step up transformer, so which will generate the 12 volts to 230 volts nearby voltage based on the currents connected in series with this transformer. So here we are going to dividing that using potential divider, that is 100:1 voltage based, and after the rectification we will get the pulsating DC, and after this capacitor we will get the pure DC, and from here we may get around 10 volts maximum, that too based on the load connected in series with the CT, and this voltage will be divided again by 10:1. So means in order to protect the microcontroller need only 5 volts of maximum. So in order to protect that, we are going to dividing that voltage by 10:1. So we'll make the circuits to get maximum of 2 volts if we place the more current in series with the CT. So by that way we are going to protect this microcontroller, and this is the CT flow. And coming to the PT flow, same here we are getting 12 volts of AC, and this is a DB107 rectifier. After this we will get the rectification filtration, and from here we will get 12 volts of pure DC. So from here we are going to give the power supply to the GSM modem, as well as the same power supply will be given to the microcontroller. So the microcontroller will get the 5 volts from this GSM modem slots, so that it start reading the input from the sensors. And from the down of this PCB we are going to distributing the same 12 volts to the motherboard, and here we are using same 10:1 ratio of the potential divider circuits in order to distribute the low voltage which should be below the 5 volts. And this is the on off switch for only like to make the voltage fault. So to make the voltage 0, then just switch off this one, then the microcontroller will get the 0 volts. It's considered as a voltage fault. The current fault will be whenever the more load is placed on the motor shaft, then the current will be increased, and it will be monitored by the PIC microcontroller. The so-called status will be continuously monitored on the LCD, and abnormalities will be identified the buzzer, and also SMS will be sent, and using the app we can monitor that. So before switching on this kit, so we need to install some apps in our Android phone, and before that just enable the hotspot with project PROJECT without space 4203 and a password should be 123456789. So after this, enable the hotspots, and we need to, as I said, we need to install the two applications, that is one network analyzer, another is Juice SSH application. So after switching on the hotspots, switch on the kits, and before that we need to remember, we should remember that inside a valid SIM card inside the GSM modem, it should have the SMS balance, and it should be valid, means it should get the signal from the subscriber, and then give the power supply. So here we can see one light is blinking on the GSM modem continuously, so at a duration of 1 second. So means it's trying to get the signal from the subscriber. So when the blinking rate is slow down to 3 seconds, then restart this motherboard from here. It's a very important step. After inserting the SIM card, after enabling the hotspot, give the power supply and wait till the GSM modem get the signal by observing the particular green LED is blinking slow. Okay, so when it blinks 3 seconds of duration, then restart this again. That's it. And there will be a welcome message on the LCD screen, and we can see the one device got connected to your phone. So there will be a beep buzzer indicating the kit got started, initialized, and you can see the connected devices. Here I am getting see that you can see that ESP is connected. And now go to network analyzer and do LAN scan and do the scan. So there we can see the ESP model number IP address 192.168.43.94. Remember that. So that is the 94 43.194, and go to Juice SSH app and go to the connections, manage connections, and add. So now here I need to enter the type is telnet, and name no need of, address is as we got from that app 192.168.43.94. okay, and port number is 8080. So these three very important: type, address, port number, and after that tick and then open that. Okay, so we can see that continuously the data will be streamed. So the voltage and the current is 0 milliamps, as the load got switched off already, we didn't on the load. So same PT values and CT values will be displayed on the LCD screen and parallelly here also. And once I switch on the load, the current values will be displayed. So as we can see that 400 milliamps data, 500, and same will be displayed on the LCD screen also. So if I put the load on this DC motor, then the current will be increased, and we set the current value for 900 milliamps, 600 milliamps only, 70 milliamps sorry. So when I place the more current, so I am holding the shaft, nothing but it's taking the more current. As you can see that the current got increased. When it crosses 7 milliamps, then that is threshold value we set it in the program. So high current, and we will get the SMS alerts also into this phone in the GSM modem. SMS. Right. So now we got the high current as we have seen that. So in order to make the low voltage, just switch off this, then the microcontroller will get the 0 volts, and parallelly we will get the low voltage message, and the same message will be appeared on the the Juice app. So like low voltage continuously will be sent. Okay, thank you.